We're here to talk about the virtualized truck. This session is sponsored by NEP, who is very heavily invested into the non-virtualized truck. So here to explain what the hell NEP is doing sponsoring a session about virtualized trucks is Scott Rothenberg. So Scott, please tell us, welcome us, and then also explain your future, so please.
So virtualization means lots of different things. I think we're going to touch on some of it. It can help scale, it can help decentralize, as it does in Australia at the Andrews Hub. It can add complexity, it can change the risk, it doesn't eliminate risk, it can change flexibility. There's no one size fits all. So I think that we'll talk about all of those things.
I think obviously, clearly a dream for you and all the remote production venues and everybody in the business would be the ability to divorce the physical hardware from the software, so that you can more dynamically repurpose the hardware. So when it's not doing something, it can be actually used to do a different task, which I guess is sort of what we're talking about in broad strokes of virtualization. But Nick, we have a slide from you that kind of lays out the mobile TV group perspective on some of these things, because we're going to touch on everything from remote production to new workflows to everything. So let's fire up Nick's slide first. And I have to get my clicker. That's what I need. That'll help. Dun, 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 dun.
Yeah,
All right, there we go.
I can start. So I'm finishing my 5th year at Mobile TV Group, and I'm 26. And so when the word at home started coming up, I felt like this was something I should investigate as a mobile unit vendor, because I'm hoping to have a long-term career in this business. And so we have thoroughly investigated it, and this image will oversimplify it for some. But at the top, that top row is a mobile unit today. And so with really 3 main components: cameras, all the engineering servers, electronics, and then you have all your operators that really use keyboards. And so this, what I would call an original at-home approach, the second row, is a great solution for some events where you're sending the cameras back to a network or a production center, where you have your high dollar electronics there and your operators there as well. And what we have discovered, I think a few others are starting to discover, is what if we separated the servers from the operators, so separating the red and the green on that bottom row. And one of the big concerns was latency, and that is no longer a problem. We have been able to test latency below 100 milliseconds, and so what this does is adds a ton of versatility, and there are a lot of different ways you can organize these blocks. One way to organize them allows for unlimited cameras, 4K HDR, so no limitation, because your engineering, your servers, your your red and your yellow are in one location, whether they're at the venue or that engineering server room is somewhere else. So it's really allowed for any type of production configuration, and now we're really waiting to see who wants to take advantage of it and if they want to take advantage of it.
Excellent, excellent. So Jeff, I want to bring you into this. Jeff Byle is with the Fox Sports Detroit. And I mean, I guess in a way, what you guys did a couple weeks ago is sort of similar to this. So do you want to kind of, tell people what you guys did with NECF a couple weeks back. It was a proof of concept, I guess. Walk people through what you guys have accomplished, because it takes REMI to another level.
Yeah, sure. We did 2 events with NECF, and basically they were found events. We have a thing called Football Week in Michigan that we're trying to get off the ground. It's more of a marketing campaign, but we're looking to increase the content within that marketing campaign. So a couple events came our way. One was a high school game in a rural area, a playoff game, kind of bringing Friday Night Lights to this rural community that could never have TV lights and announcers and the pomp and circumstance there. And the other was a high school all-star game in a field house, a place where they don't generally have TV. So in order to do this, we had to try to find an economic model that fit. And so NECF approached me, and we had a conversation. And basically, we did an at-home production out of our studio in Detroit that had never done a live event before. But it was a little more than an at-home telecast because we had facilities in other cities across the United States and the world, actually, that were helping produce that event. So, example, we had, we had an EVS in our studio, but we also had a Dreamcatcher in Boston that was working with our studio at producing the game. And that's just one example of some of the things that we did with those two games, using the bonding technology, using LiveU. We worked with LiveU very extensively to get the cameras and audio back. But that was basically our trial foray into this.
So I guess the goal there, or the vision there, is you have underutilized equipment in remote locations that potentially, and operators who may be sitting across the ocean, for example. Let's take graphics operators, because I think NECF might use this. So you have graphics operators who are sitting in Abu Dhabi who aren't very busy because it's the middle of the night when events going on the East Coast, and there's the potential to have them working on the event remotely, and then just handling the graphics aspect from that facility, or to have that one EVS operator in Boston, or potentially, let's say when Phil's trucks or Scott's truck is sitting at the Super Bowl and it's quiet for a day because the game's not for another 2 days, that those servers could potentially be used and connected to another location. Sort of, right? I guess?
Yeah. That is the NECF model and probably some of what Nick's trying to do here. For me, it's being able to do a game rather inexpensively, and that, my studio itself, the infrastructure there isn't equipped enough to do a full live event, right? It wasn't built for that. So being able to utilize and maximize my facility, and then also have the capabilities of using other facilities wherever they are in the world, to get that telecast done at an economic level for me that's. I'm an executive producer highlighted the producer type. I'm not that technical guy. I still don't understand completely that, but we're trying to figure it out. And it worked very well. There were a few communication issues. When you get a producer and director that are used to doing games out of a truck and have all of those facilities that are at their fingertips and usually work 99% of the time, the heavy lifting was there, but it was worthwhile. We saw how the technology works, and it was really eye-opening for a lot of people that I work with.
Now, how did you deal with the latency issues, which I guess would be one of the challenges, because you're also using bonded cellular technology, which can introduce. So how did you kind of get around those issues, or?
They were actually very light, surprisingly. The Dreamcatcher in Boston had a latency of about a second. So the director just changed his cadence. He would roll something, wait, take. So it was an extra step for the TD and the director and a thought put into it. But once they got moving, it actually is pretty light.
Right. And I guess the one, you mentioned you don't know the technology, but you do understand the financial side of things. And I guess the real reality for the industry is if ESPN, where you guys are going to be producing thousands of events that really don't have a huge audience, there's going to have to be a new economic model. So I guess to Scott and Nick and to Jeff and to Joop, as far as what do you see as the financial pressures that are going to drive these virtualizations?
One thing to add on to Jeff while we have this still up is in this model on that bottom row, the control systems are relatively inexpensive compared to the whole unit. And so when you put engineers and the servers back at the venue, Jeff could build another network control room for a couple $100,000 instead of a couple $1 million. And so that really helps on the financial side, is keep all the systems on the Mobian where they are, allow that Mobian to do regular events the next day, and then turn to doing at home to save money the next.
Yeah. Apart from the thing that we didn't touch on is actually the progression in formats and requirements on a sports rights deal terms. So with virtualization, you can actually, on a game basis or on a season basis, upgrade to your latest video standards, or you can renegotiate your bandwidth requirements because you can change your codecs or you can change your functionality basically on the fly. So that's another, apart from remoting multi-viewers and production switches, etc., and save a lot in the remote production cost. But also, you can actually, when new video formats come out, when the codecs become more performant, you can upgrade actually on the fly without, basically on a zero-touch basis. So in-band, you upgrade your, because everything is software, so you upgrade your codecs, your number of channels, your number of DVEs, etc., etc. Right. So that's another element to the financials.
So you want to walk through these slides?
Okay.
So Jeff, hang on. This is going to be.
How do I go back?
Yeah, I'm paying attention.
So we're talking software versus hardware visualization, right? So you want to.
Yeah. So I put some slides together. Aperi started 5 years ago with virtualization, basically building from scratch. So I've here a picture of basically showing virtualization from the venue all the way across the video chain. So basically what virtualization is that you can deploy, commission, start, stop, remove broadcast functions in your network, decentralized at the venue, in the truck, in your production center or your studio, all the way through to play out OTT with in-band control, so zero touch. And that on an instant basis. So what you need for that is basically a generic compute, which is performant for low latency applications. I'll come back on that, like sports. You need a hypervisor, a middleware OS layer that actually manages your broadcast functions to run as microservices or apps on your compute. So you could have in your OB van, you could have your multi-viewer for one game over there locally in the OB van, but for the next time you actually, for the next game, you actually deploy that same multi-viewer with a license key change. You see these in the graphics, you see the license key going over your in-band management to activate or deactivate your multi-viewer. And it is as easy as it's depicted here in operation. And the third element is you need an app store with hundreds of broadcast functions. So everything that we do today, from audio processing, video processing, data processing, talkback systems, everything basically is an app or a microserver that is enabled via hypervisor. And the technology, the key technology in that is container, like Docker management systems. So these are kind of technology architectural elements that are from other industries that you need to apply here. So a little bit more in detail, if on the left you see here a normal virtualized architecture where you have CPUs and GPUs, servers that run this OS system, for example, VMware, and in there you can run your functions on a very agile basis. This is done in normal data centers.
So so the functions, just real quick. So Aperi, you guys are about the compute servers, right? We
have that as well, but it's you have now AWS and others that provide FPGA-based compute servers as well, where you can run our software on top.
Right. So for the applications, let's walk through that just a little bit. So explain. Yeah. You have an app store, I guess, for lack of a better word.
Yes.
So you go to traditional hardware-based, I guess, software companies that used hardware, and then have just said, we want to just take your software and license it through. So walk through the relationship you have with those providers.
Right. Yes. So the whole idea is that actually the hardware is not important where it comes from. It can be your own server, or it can be from AWS in their F1 services. It doesn't matter. What is important is the middle layer, and actually it's, if you show it here, because the one element that is very important, it needs to be an FPGA based. If you want to go live media to millisecond latencies, you need an FPGA-based server. And they are now generically more available, right? We built the first one because 5 years ago there was no one available. So you need at the truck in your stadium, you need these compute servers. They give you, the FPGA gives you 10 times more power in speed. It gives you 10 times less power usage, and it gives you 10 times rack space.
FPGA is field programmable.
And they're still programmable on the fly, right? Like CPUs and GPUs. And you put them in a wire speed IP network fabric compared to most of the data centers that are more software fabric connected. And you get these millisecond latency. And then you have this hypervisor layer, which is actually the secret source of these solutions, right? Because you must be able, in a low latency environment, to deploy functions and start them, stop them, and remove them, and et cetera, et cetera. Right. So that is the vStack layer for Aperi, but in generic terms, that's your hypervisor hardware virtualization level. So then you come to the App Store and the functions. You can run hundreds of different functions on the same compute, right? So your hardware is always the same. It's always cabled up in the same way, and you have your encoders, decoders, etc. And what this model allows you is to take the best encoders in the industry and your best multiviewers in the industry, because they have the domain knowledge. You love them, you know, your operators, everybody loves them, knows how to deal with them, and they run now virtualized on your compute without having actually changed the user interface of it. Yeah? In that way, you're not bound by your fixed function hardware, right? You have a purple box from X, and you have a yellow box from Y, and so on. That is going away. So we actually completely take away the physical element of running your broadcast functions and your workflows. And with that, you get the decentralization, you get your upgrade on the fly. You can pay only for a game. Your license, you pay just for the game, 3-hour licenses. And you can reuse these computes. If they are idle, you can use them for another event as long as they are connected in your network. So it's not new. A lot of industries went this way. What is new that we can do it decentralized. So virtualization doesn't mean that you need to run in a data center in the cloud with a third party. You can run your virtualized environment, you know, in your truck companies, in your operations, and you can have it hybrid at the venue, in the truck, and in a data center. Right. As long as you combine it all with your OS layer, that is that hardware virtualization level. And with that, and you get to milliseconds of latencies rather than the typical, you know, CPU-based and GPU-based that typically you add seconds to your. So I try to depict it. You know, everybody talks about going to IP, but it's kind of meaningless to go to IP. You get some advantages, but if you don't virtualize your environments, you actually don't gain that much. And I'm now 31 years in the industry, having been with Grass Valley, the Philipses, the EVSs, etc. But I think this is a more profound transformation of the industry than going to digital or going to HD. Right. Virtualization will bring all the benefits that we've seen in the enterprise world that completely went to a virtualized environment and to IP many years ago. That is now possible in the live media space. And the good thing is, on the right, you see some other industries that are moving to the same virtualized environment, and they had the same problems, latency. How can I have a lot of big data, a lot of data at the same time being crunched in milliseconds and get my outputs at the end? And how can I delocalize that, etc.? And that is, so we are actually on a trend of all these low latency, the high computational markets they are called, towards virtualization, and we are one of the industries that will follow that. So it's there, and the good thing is all the technology is standard and shared with all these industries.
Right. So Scott, what's your take as far as the role that this kind of philosophy would play within your trucks, your
so I'll
hubs?
play the kind of wet blanket here for a second.
Yes.
The one thing we need to remember, the little blue arrows on the virtualization slide might cost a lot of money. What we found is when you compare connectivity costs, say, the UK to Australia, the UK was 5 times the connectivity cost of Australia. And when we look at it here, it is not consistent from state to state, venue to venue, location to location. One of the things that we've all counted on and enjoyed is price consistency and cost consistency across events that go from point A to point B and things like that. It's a factor. I'm not saying that it's good, bad, or indifferent. It just is something we need to think about. The other thing is that while we can run any of the processes on general compute hardware, you can't run all of them on at the same time. And I think one of the things that you would need a very, very, very large computer or many of them. One of the things we've all gotten used to and how operations departments work is we ask for a truck, we ask for certain specs and other things, and I don't think know a lot of how it's going to be used on any given day. How much transcoding are you going to use versus how many replays and what codec are they going in? What are all the details of a production that are needed to be known, but they're not known at the time of booking? And when you're looking at a virtualized environment, all of that you do need to know up front so that you can deal with those inevitable changes and those inevitable curveballs that all happen. Oh wait, I want to run this in a 3D move instead of a 2D move. In a virtualized environment that is optimized, that could be an issue. It's something that you need to change. None of these are insurmountable, but this isn't something you would just do tomorrow. And this isn't only a technical issue. This is a workflow overall issue and a learning process for all of us. I think the other thing is just back to what are we trying to accomplish? I mean, we currently in our Hilversum location in the Netherlands, we license out control rooms with MEs by the day, by the hour, morning, night. We know they're studio-based shows. We know what's going on. It's not an unlimited what you can do because it is a fixed number of MEs. You've got a fixed number of physical inputs that go, that go into the switchers that get carved up and virtualized. In an IP environment, that probably becomes more flexible and more interesting. In an SDI environment, there's still encapsulation, de-encapsulation that you need to do, and you need to have some numbers to that and be prepared for it. So, I mean, I think that it's a great topic, and I think as we were talking before, this is, down the road that this goes. I just don't want to, we shouldn't leave to believe that Mobile TV Group, NEP, Game Creek, anybody is going to have a completely virtualized truck doing a game this weekend, and there. But I think that there is certainly also the other thing is that this isn't an all or none. We could virtualize lots of processes that do things, and we're already doing that. There's a lot of the manufacturers here in the audience that have processes that maybe it's frame sync, color correction, cross conversion that is all virtualized on various things, and you don't know how much you're going to do, and you can do those on a given day, week, per month. And then the last thing to all think about is the pricing. I have yet to see a price from anybody here by the hour for any service, and I would challenge everybody here to show me. All right, I have yet to see one that makes sense if we're going to do it. If you're going to run a truck company and use things 5 days a week, as I think most of us do, if not more, where it makes sense, where you're renting things, by that time.
Right. Well, the financial situation is obviously you're talking about a whole entire industry potentially going to software-based models versus hardware. I mean, there is a value to a company to sell a big purple box. That can they recoup that investment if they're not selling the box, if they're just selling the software? So there's lots of questions to be debated and discussed. So I do have one more quick little thing. Hey Dan, can you cue up that video, the Japan virtual? So this is from. Hopefully it's going to pop up soon. This is from Interb. This is Tokyo Broadcast Systems does this demo. It's a VR, and he's technical directing a show that was on the set using VR goggles. I don't know if you could do this for 4 hours doing a football game. You might get a little crazy, but you'll see his little virtual hand pop up here soon.
Saves on a gym membership.
Exactly, there you go, see? So there you go. So that's another version of the virtualized future from your living room
It's
couch.
like a can versus a want here. Can.
Yeah.
Cool. Very cool.
It was like a 5-camera show, but you know they were just dabbling.
Yeah.
So, so Jeff, what's your take on the next step as far as what you guys accomplished? Do you see it more again for these events that otherwise wouldn't have been produced? Is that where the sweet spot is for this virtualization?
Yeah, I'm not sure. I would agree. We're not going to do Monday Night Football is not going to be done this way next week. But all I know is that it worked for the 2 events that we were able to plan for. Low impact events. Although the second event had RF, had wireless mics, had robos. So I mean, we did have some infrastructure into the second event we did, but where I sit in the RSN world, yeah, it's not something that we're going to be doing pro product with later this year for sure. But as far as one-offs, the lifting was pretty heavy from a planning standpoint. But I think that'll ease in time once people understand the workflow. So that's kind of my take on it.
So Nick, what's your being the 26-year-old in the panel?
Well, we not only tested this in our shop, we did test it at an MLB game with directors and replay operators. The replay operator didn't believe us that the server was 3,000 miles away. He was able to spin the EVS, and it was going back 3,000 miles, spinning on the EVS, and then sending the multi-viewer back with what he should see. He didn't believe it. And so we have done it. It can be done. It's more, and the reason why we did that is to let Jeff know, hey, you know, this can be done now, and you don't want to do it? Totally cool with us. But if you need to get some, you know, more efficiency out of a certain operator position, we can centralize them. They can do multiple events a day if the volume and the schedule works. And so it does depend on your definition of virtualization and whether you're talking about just a complete cloud approach or moving some systems. But we did everything on a mobile unit for a Major League Baseball game successfully.
Yeah, I think Scott is right that it will take some time for an installed base to move over to full virtualization, and when that makes sense, right? Because bandwidth is an issue, cost is an issue, and depreciation is an issue. But the fact that we now have connected stadiums in Australia, in France now is rolling out, in England, and soon here in the US as well, with one of the major leagues, it's moving in that direction, and you can virtualize islands. The one thing that I would like to say, being in the industry for such a long time, is the time to buy fixed function boxes. Even though you can switch between 3 different codecs on the fly, that time is over, because you have to throw it away in a few years. Going to generic computes that can run your functions, whether you do it on a static basis or on a fully remote production per minute or per hour basis, it is always a better bet for the future than staying with the fixed function boxes.
So, but Scott hit on the cost of the connectivity in Australia versus the UK, and I remember talking with someone at Wimbledon. You know, in order to get those circuits at Wimbledon, you have to rent them for the whole year. You can't only rent them for the three weeks, which seems kind of crazy, a little wasted money. So, do you see? Is there a chance for the market to catch up? So because to your point, you can't do the hour basis unless the people who are providing this are going to say, okay, this makes financial sense for me to do this by the hour.
Well, we shouldn't necessarily link virtualization and remote production necessarily together. Right. You know, that virtualization is a capability that could be used in a studio environment. It could be used in a fixed truck. It has other applications with distributed production that it might help that. But they're not mutually exclusive, and they're not dependent on each other there. So, I think it's another tool in the toolbox that allows us to make productions differently. And I think that's, you know, what a lot of is exciting about this time in the industry is there's a lot of different ways to accomplish the same goals. And how do we do that? And it's just another tool.
Yeah, and my experience with working with the carriers is that if you can virtualize your endpoints and you pay almost, you know, cost price for your compute and for your switches, and you pay only the real added value service, which are the software functions, as and when you need them, they're more prepared to go this way and give you also fixed term rates on the bandwidth. But in the past and up till today, if they have to depreciate all the asset cost that they bought up front in order to get the software of the media service enabled, then it becomes very difficult for them to give hourly rates, etc. Yeah. So
I was just going to say, Joop, your approach of moving the key is really helpful to companies like ours. But we were able to do the test with 1 gig, and that's thanks to NetInsight and CenturyLink that helped us with that test. But 1 gig is relatively low and relatively common now in pro venues.
And look, the gigs will increase and the connectivity will increase. So it's always it's gonna be fascinating to see how this all kind of spins out over the next 5 to 6 years, 7 years, 10 years, 20, till you're 20. Well, let's see, you're 26. So in 40, 50, you got a lot. In 2050, you'll be how old?
In 2050?
50 years old, roughly. Wow, so young. All right.